Right. So I felt like I needed to do another maths video because, Sling Note was so bloody popular. And I did some more crazy maths that I believe I need to share with you because it's very important and, like, controversial because everyone believes in flat Earth, don't they? Uh, Basically, I did a little. Everyone's talking about flat Earth, so I thought, okay, right, let's do a little bit of research into this. Um, and it turns out they don't believe that gravity exists, right? We know from I know from a Vsauce video because watching Vsauce makes me instantly 7 times smarter than anyone on planet Earth. I know from a Vsauce video that if a flat Earth had gravity, then when you're on the edge of the planet, you'll just tumble towards the center like it's a giant uphill, you know. So they don't believe in gravity because they clearly knew that that's what would happen on a physical standpoint because they are gods of physics with their mega minds and all of their 2 brain cells. Anyway, I'm here on the Flat Earth Wiki. The Flat Earth Wiki that has their frequently asked questions. This is their website. This has what they believe in. I mean, look at that. They've got a gif of the sun and the moon spinning around. That's so fucking legit. Anyway, here, physics and cosmology. Why doesn't gravity pull the Earth into a spherical shape? They start talking about gravity. Blah, blah, blah. They believe that gravity doesn't exist, and the quote-unquote gravity we experience is due to the fact that the Earth is constantly accelerating upwards at a rate of 32 feet per second, or 9.8 meters per second squared. Now we know this number. At least people that do physics know this number. 9.81 meters per second squared is the force of gravity. That's what we feel pulling us down. That's the force. If we're 9.81 meters in the air, it will take us 1 second to hit the ground. Maybe. Something like that. Anyway. My point is, I thought about that after I saw that and I went, hang on. Acceleration is a constant increase in velocity. Earth's been around a long time. And if we've been accelerating this entire time, we're fucking wildin' right now. We are going supersonic. Sonic doesn't even fucking matter. We are Mach 7 million. We're fucking going so fast. We're time warping right now. Right? So I thought, okay, what's the maths of this? What is the maths of accelerating at 9.81 meters per second upwards since Earth has been created? So let's get out our let's get out our little notepad here. So we know from Google, from scientific blah 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 whatever, that the Earth is 4.543 billion years old. Now, billions of years isn't really helpful to us in a mathematical standpoint. We want this in seconds. So we take our billion is times 10 to the 9. So we've got 4.543 times 10 to the 9 years. So if we times that by 365 for days, we get 1.658. Hang on. So Earth has been around approximately 1.658 times 10 to the power of 12 days. It's a lot of days. I'm gonna spare you the bother of me writing for 7 years. Basically, if we times that by 60, if you times your days by 24, you get hours. If you times it by 60, you get minutes. If you times it by 60, you get seconds, which is what we want. We've got it in seconds. The Earth has been alive. The Earth has existed for 1.433 approximately times 10 to the 17 seconds. Now that's something we can work with. Seconds we use in physics. So I went to our good old friend, the kinematics equations. So we've got, we got S, U, V, A, and T. We got SUVAT. Now we know what U is because we don't know what U is. We assume that when Earth was created, it was traveling at 0 meters per second. Because why wouldn't it? It's not being created traveling at light speed already. Final velocity is what we're trying to find out. We want to find out what the final velocity is. Our acceleration is, as we know, 9.81 meters per second squared upwards, and our time, which we've now figured out, is 1.433 times 10 to the power of 17 seconds. Now, the equation we want to use for this is V equals U plus AT. v equals u plus at. We know that u is 0, so it's v equals at. So if we take 9.81 meters per second and times it by 1.433 times 10 to the 17, we get a lovely answer that our final velocity through Earth, through space-time, is 1.405 times 10 to the power of 18 meters per second. That is... I can't remember what the value was. It was... hang on. That is 4.7 trillion times the speed of light. Now, I don't know if flat earthers believe in relativity or not. So, if they don't believe in relativity, because why would they? They have about 2 brain cells as it is, they're not going to believe in Einstein's shit. But just on the offhand that they do believe in relativity when you get to the speed of light, this isn't our answer. This isn't the answer we want. Just for reference, if they don't believe in special relativity, this means that flat earthers genuinely believe that we're travelling at over 4.7 trillion times the speed of light, and we're currently at a speed of about 1.405 times 10 to the 18 meters per second. But I decided there's more than one route, isn't there? As if they believe in relativity. What happens then? And I thought, I know where this is gonna go. So let's start again. Let's keep our speed. Let's keep this lovely number here, because this is a number that we want. 1.405 times 10 to the power of 18. So that's our speed at the moment. So I went to thinking, okay, if they do believe in relativity, we need to turn this into a mass. Because how relativity works is it says that as you approach the speed of light, the more energy you put into something, the speed will increase, right? You've got kinetic energy, mass stays constant, so if you have a higher kinetic energy, it's because the speed is increasing. Our equation for that is a half of mv squared. Now, since you can't, in physical terms, you can't exceed the speed of light, what happens when you get close to the speed of light is something very funky. If you keep on putting energy in, the kinetic energy will go up. 0.5 isn't going to change because that's a constant. Velocity can only go so high because you can't get higher than the speed of light. Therefore, when you're near the speed of light, the mass increases. So what we're going to do now is we're going to figure out how heavy the Earth would be, the mass of the Earth, if they believe in relativity. So you do half mv squared, and the mass of the Earth is 5.972 times 10 to the 24 kilograms. Times 10 to the 24 kilograms. So that's our mass of the Earth as it is. So with this speed, the kinetic energy that we have, Ke, is equal to 0.5 times 5.972 times 10 to the 24 times our speed squared, which is a fucking massive number because it's 1.405 times 10 to the 18 squared. So if we put this in our calculator, we get a kinetic energy 5.898 times 10 to the 60 joules. That's a lot of fucking energy. So kinetic energy is energy, so we use that as E. And our relativistic formula is E equals mc squared, because you can't go higher than c, so you just assume that that velocity is c. And now we've got our kinetic energy, we can work out the mass of the Earth according to the special relativity of the Earth if it was at 1.405 times 10 to the 18 meters per second. So we've got our kinetic energy as 5.898 times 10 to the 60. Now we want, so since we want mass from this equation, we now have our equation as E divided by c squared is equal to mass. So if we take 5.898 here, times 10 to the 60. If we take this here and divide it by the speed of light, 3 times 10 to the 8 squared, then we'll get our mass, our relativistic mass of the Earth, which gives us a mass of 6.554 times 10 to the 43 kilograms. Now, I don't know about you, dog, but that's pretty fucking heavy. So I went, alright, what can we do with a mass like this? And I'll show you what we can do with a mass like this. We can do some fucking funky maths. So, we know what black holes are. If you get something that's dense enough, it has a high enough mass in a small enough volume, you get a black hole. And there's an equation for that. It's called the Schwarzschild radius. And the equation for the Schwarzschild radius, which we'll call RS, is equal to 2 times the gravitational constant times the mass of the object divided by c squared. So the gravitational constant is 6.67 something or other, 408, times 10 to the negative 11. That's our gravitational constant. It's just a thing that you get. We have 2, we know what the number 2 is, that's a constant. So we've got 2, and we've got our mass, which is 6.554 times 10 to the power of 43. So this is our equation. We've got that, and it's all divided by the speed of light squared. Now what this will do is it will give us the Schwarzschild radius, which is the minimum radius that something of a certain mass has to have in order to become a black hole. Like, for Earth, that has a Schwarzschild radius of, I think it's a few centimeters. If you squished the Earth down to the size of a marble, it would become a black hole because it's so dense. The Schwarzschild radius of the Earth, when it's travelling near the speed of light and has this mass of 6.554 times 10 to the 43, we get an answer of 9.72. Now you might be thinking, oh, that's alright. No, I left out a bit. It's 9.72 times 10 to the 16. You know how big that is? You know how fucking massive this is? That's meters. Alright, that's the radius that the Earth at this speed has to be minimum to become a black hole. I'm gonna let you know how big that is. I don't know the exact value, but the radius of the Milky Way is times 10 to the 20. And that thing is humongous. The Milky Way, we're like an atom in the Earth compared to the Milky Way, right? And according to this, we're only like 10,000 times less than that. The radius that Earth has to be is about 10,000 times less than the radius of the Milky Way, which is fucking bonkers. Just for reference, the radius of Earth is 6,371 kilometers, which, I mean, if we put that into meters, it's just like 6 million. It's 6,371,000, otherwise known as 6.371 times 10 to the power of 7, 6, 8, 9, 3, 6, times 10 to the 6. Now look at that! Basically, what this means is that either way you look at it, flat earthers are positively brain dead. I mean, we all knew that to start, but I've mathematically proven that flat earthers are retarded. Because, according to them, if they don't believe in special relativity, then we're currently travelling at 4.7 trillion times the speed of light, which, I mean, I'm not sure about you, but I think I'd feel if we were going that fast. I've kind of got a feeling that I'd be, like, mush on the floor. And, like, we would have hit a black hole or something, or cut through the space-time continuum and travelled back into the past or something. And if they do believe in special relativity, then the kinetic energy of Earth is so high, and the mass under relativistic forces of Earth is so large, that we actually exceed the Schwarzschild radius by times 10 to the 10. We exceed it by, like, 10 billion times. With, like, if the Earth was 10 billion times bigger than it is right now, we'd still be a black hole from how fucking massive from how dense the Earth is when it's traveling at the speed of light. And it has its kinetic energy. I have now mathematically proven that flat earthers are fucking dense. They're denser than the Earth. They're denser than this. I bet the Schwarzschild radius of a fucking flat earther is like, that is just smaller than themselves. They'd fucking, if they were any smaller than they were, they'd turn into a black hole from how fucking dense they are. Alright, thank you for listening. That's all I wanted to say.